What is geology? Geology, one of the most core science disciplines with physics, chemistry, and biology, is the search for the knowledge about the Earth, how it formed, evolved, and how it works. Geology, often presented in the broader context of geosciences, a grouping of disciplines specifically looking for knowledge about the interaction between Earth process, environment, and societies.
Moving forward to structural geology. Structural geology, tectonics, and geodynamics form a coherent and interdependent ensemble of discipline. The aim is to search for knowledge about minerals, rock, rock formation, interaction between earth processes, environment, and societies. Structural geology alone aims to characterize the formation structures, or what we call geometry. The other one is to characterize flow paths followed by particles during their formation, or kinetics. And lastly is to infer direction and magnitude of forces involved in driving the formation, or what we call dynamics. Moving forward to structural geology. Structural geology, tectonics, and geodynamics form a coherent and interdependent ensemble of discipline. The aim is to search for knowledge about minerals, rock, rock formation, interaction between earth processes, environment, and societies. Structural geology alone aims to characterize the formation structures, or what we call geometry. The other one is to characterize flow paths followed by particles during their formation, or kinetics. And lastly is to infer direction and magnitude of forces involved in driving the formation, or what we call dynamics.
Outcrop. In the mountainous and submountainous tracts, and also in shallow plains, exposure of rocks may be easily seen, forming sides of valleys or caps of hills, or even uplands and slopes in level fields. An outcrop is simply defined as an exposure of a solid rock on the surface of the earth. So when weathering and erosion expose part of rock layer or formation, an outcrop appears. An outcrop is the exposed rock, so named because exposed rock or crops out. Outcrop provide opportunities for field geologists to sample the local geology, photograph it, hold, touch, climb, hammer, map, snip, lick, chew, and carry it home. Outcrop dimensions include width or breadth, the distance between the top and bottom edges of the bed as measured on the surface of the ground in a direction perpendicular to the strike of that particular bed. So outcrop width is mostly a function of the bedding depth in the topography. Next is thickness. It's the perpendicular distance between the top and bottom surface of the same layer as seen in the vertical section at right angles to the strike of the layer. Lastly is depth, the perpendicular distance between the ground surface and the top surface of the particular layer. So basically, the difference between thickness and depth is thickness is in the same layer of the bedrock, while depth is in another layer.
Folds. Folds may be defined as undulations or bends or curvatures developed in the rock of the crust as a result of stresses to which these rocks have been subjected from time to time in the past history of the Earth. Also, a fold is a struct of originally planar surface such as sedimentary strata that are bent or curved during permanent deformation. Folds in rock vary in size from microscopic wrinkles to mountain-sized folds. They occur as a single isolated folds or in a periodic sets. Part of a fold. Limbs. These are the sides or flanks of a fold. Also, the limb of a fold is that part of the folded surface between adjacent hinge points or zones. Hinge. In a folded layer, it is the point that can be found where curvature is maximum in one limb end, and the other limbs start from the point. When rocks occur in a sequence and all their hinge points are joined together, they make line called the hinge line. Hinge is the line joining points of a maximum curvature on a folded surface. This line may be either straight or curved.
Axial surface, a surface plane or non-planar, obtained when the hinge line is traced throughout the depth of a fold sequence. The imaginary surface, bisecting the limbs of the fold. Axial plane is an imaginary plane that passes through all the points of a maximum curvature, inclined or horizontal in nature. The plane that results when all of the points of maximum curvature in all of the beds comprising of fold are joined. Axis of a fold is simply defined as a line drawn parallel to the hinge line of a fold. The intersection of the axial plane with one of the strata which the fold is composed.
Plunge of a fold. The angle of inclination of the fold axis with the horizontal as measured in the vertical plane is termed the plunge of the fold. Class and true. Most folds are variations of two general forms, up arch and down arch bends. The line running through the highest point in a up arch fold defines its crest, whereas the corresponding line through the lowest point in a down arch fold makes it through parts of a fold. The angle of inclination of the fold axis with the horizontal as measured in a vertical plane is termed the plunge of the fold. Most folds are variations of two general forms, the down arch and the up arch bend. The line running through the highest point in an up arch fold defines the crest.
Classification of folds include anticlines and synclines. Anticlines are folds in which the strata are up arc, meaning it convex upwards. And synclines are folds in which the strata are down arc, meaning it convex downwards. Depending upon the nature and direction of the stresses, the axial plane in a resulting fold may acquire any position in space. That is, it may be vertical, inclined, or even horizontal. The following main types are recognized on the basis of position of the axial plane in the resulting fold. There are symmetrical folds, asymmetrical folds, overturned folds, isoclinal folds, recumbent folds, conjugate folds, and box folds.
Are those fractures along which there have been relative movements of blocks that pass each other. The entire process of development of fractures and displacements of blocks against each other is termed as faulting. These are fractures in the crustal layer of Earth. This fracture is the response of the ground in the stress or force that is caused by the movement of tectonic plates in the Earth's crust. Once this fault moves, seismic waves or production will occur. There are factors considered in the classification of faults. The apparent movement of the disrupted blocks along the fault plane. 2. The direction of slip. 3. The relation of fault attitude with the attitude of displaced bed. And lastly, the amount of depth of the faults.
The three types of faults are normal, reverse, and strike slip fault. Normal fault, a disc slip fault in which the block above the fault has moved downward relative to the block below. Number 2, reverse fault. In the field of geology, a reverse fault is a deep slip fault in which the hanging wall moves upwards relative to the footwall. Strike slip faults are vertical or nearly vertical fractures where the blocks have mostly moved horizontally. If the block opposite an observer looking across the fault moves to the right, the slip time is termed right lateral. If the block moves to the left, the motion is termed left lateral.
Joints. Joints are defined as divisional planes or fractures along which there has now been relative displacement. These fractures divide the rocks into parts or block, and unlike in the faults, the parts has been not suffered any movement along the fracture plane. Joints may be open or closed in nature. The former are those in which the blocks has been separated or opened up for small distances in a direction at right angles to the fracture surface, while the other latter there is no such separation. So the joints are a cracks or a fracture present in the rocks along which there has been no displacement. Joints occur in all types of rocks. They may be vertical, inclined, or even horizontal. Also, joints are formed as a result of contraction due to cooling or consolidation of rocks. They are also formed when the rocks are.
On the basis of geometry, there are three: the strike joints, dip joints, and oblique joints. Strike joints are those joints whose horizontal direction is parallel to that of the strike of the rock. Next is the dip joints. Dip joints are those joints that are parallel to the dip of the rocks. Lastly is the oblique joints. Oblique joints are those joints where the strike of the joints is at any angle between the dip and the strike. On the basis of genesis or origin, there are also three: the tension joints, the shear joints, and the compression joints. Tension joints are those joints which are formed as a result of the tension forces acting on the rocks. Next is shear joints. Shear joints are those which are due to the shearing stresses involved in the faulting and folding of rocks. Lastly is compression joints. Rocks may be compressed to crushing, and numerous joints may result due to the compressive forces in this case. In the core regions of the fold where compressive forces are dominant, joints may be related to the compressive joints.
Engineering considerations. Geologic maps are uniquely suited to solving problems involving Earth's resources, hazard, and environment. Geologic maps represent the distribution of different types of rocks and superficial deposit, as well as locations of geologic structures such as faults and faults. Geologic maps are the primary source of information for various aspects of land use planning, including the siting of buildings and transportation systems. It is said to be suited to solving problems because we will able to study the structures of the soil if it can support the infrastructure that we will build. And we will also identify the grounds fault and fault before starting the construction for the safety of the client and the workers.
Faults developed in the areas of work are important for a civil engineer, in that this makes his or her work more complicated. If these structures are not thoroughly investigated and properly interpreted, any civil engineering project standing on or driven through the faulted rock may prove not only uneconomical in the ultimate analysis, but also unsafe as well.
Engineering consideration. The safety of the civil engineering structure built on or near a faulted rock can be assessed around the tectonic history of the area under consideration must be known.
The tectonic history of the area under consideration must be known thoroughly. Faults with any significance are always associated with earthquakes.
Such a study will virtually mean obtaining information about frequency of the earthquakes, as also their magnitude and effects that they have left from time to time on the rocks on the region. The exact position of the area of construction with respect to the seismic zoning of the country must be thoroughly established.
Three fundamental types of faults are commonly distinguished on the basis of apparent movement. Normal faults. Normal faults are inclined fracture where the blocks have mostly shift vertically. Next. Reverse fault. The block above the faults move up relative to the block below the fault. Next. Strike slip faults. Strike slip faults, vertical or nearly vertical fracture where the blocks have mostly moved horizontally. Joints. Joints are defined as division planes or fracture along which there have been no related displacement. This fracture divides the rocks into parts of block, and unlike the faults, the parts have not suffered any movement along the fracture plane.